Hey everyone, so great to see you back. There's this myth that keeps popping up in science groups every now and then, and it's a real head-scratcher. The idea is that thanks to the Coriolis force, when you flush a toilet in the Southern Hemisphere, the water will swirl clockwise, and if you're in the Northern Hemisphere, it'll supposedly swirl counterclockwise. Now, it sounds simple enough, but actually trying to prove or disprove this is surprisingly tricky. The obvious reason? Not many of us have two toilets, one in each hemisphere. Today on Facts 5 Minutes, we're going to dive into 3 key questions. First, what exactly is the Coriolis force? Second, is it actually true that toilets in the Northern and Southern Hemispheres flush in opposite directions? And third, if they do, is the Coriolis force really the reason behind it? All right, let's get started. So first up, the Coriolis force, also known as the Coriolis Effect. This is an inertial force that was described way back in 1835 by a French scientist named Gaspard Gustave de Coriolis. Basically, Coriolis stated that in a rotating reference frame, an inertial force acts to the right of the direction of motion for counterclockwise rotation and to the left for clockwise rotation. Think of this experiment done by researchers at MIT. They had 2 students playing catch on a rotating platform. It was pretty boring until the platform started spinning. Suddenly, they started missing their throws. A stationary camera showed that the ball was still traveling in a straight line, but the person catching it had moved. However, a camera mounted on the rotating platform showed the ball not going straight, but veering off to the right of the thrower. So, the ball wasn't actually changing direction. It was the rotation of the reference frame that made it look like it was. Now, our planet Earth is essentially a giant rotating reference frame. It spins on an imaginary axis at about 1,600 kilometers per hour at the equator and a measly 0.0008 kilometers per hour at the poles. On Earth, the path of an object moving north to south will always be deflected to the right in the Northern Hemisphere and to the left in the Southern Hemisphere. One of the most vivid examples of the Coriolis effect in action on Earth is hurricanes. You might not have noticed, but hurricanes in the Northern Hemisphere always rotate counterclockwise, while those in the Southern Hemisphere always rotate clockwise. Here's how it works. Hurricanes form when warm, moist air over tropical oceans rises, creating an area of lower air pressure underneath, what we call a low-pressure zone. Air from surrounding high-pressure areas gets sucked into this low-pressure zone, becomes warm and moist, and rises, further lowering the pressure below. This process builds up large clouds and thunderstorms. When they get big enough, they start rotating around the central low-pressure area. To make it easier to visualize, imagine flattening out the Earth and putting arrows on it representing the speed of its rotation around its axis. Longer arrows mean faster rotation, and shorter arrows mean slower rotation. Now picture a gust of wind meeting a cloud that originated at the equator. This wind will be moving at the Earth's rotational speed at the equator, the fastest speed. As it travels towards the poles, its inertia keeps its speed relatively constant. But the Earth's rotation speed at the poles is significantly slower. As a result, the wind moves faster than the ground below it, causing it to be deflected to the right in the Northern Hemisphere and to the left in the Southern Hemisphere, from the cloud's perspective, of course. So, for hurricanes in the Northern Hemisphere, clouds moving up from the equator have a higher velocity and are deflected to the right relative to their starting point. Clouds moving down from higher latitudes, which are slower, are also deflected to their right, which looks like a leftward deflection to us. When they reach the low-pressure center, they get pulled in and rotate around it, forming counterclockwise storms. In the Southern Hemisphere, clouds moving down from the equator are deflected to their left, our right, and clouds moving up from the South Pole rotate around the low-pressure center, creating a clockwise swirl. Besides hurricanes, the Coriolis effect is also something that needs to be carefully calculated when firing long-range artillery, launching rockets, or piloting long-haul aircraft to make sure everything hits its target. With all these examples, you can definitely say that the Coriolis effect is real. Now for our second question. Is it actually true that toilets in the Northern and Southern Hemispheres flush in opposite directions? At first glance, it might seem like it. I mean, I've got 2 toilets at home, and both of them create a counterclockwise swirl. What about yours? Let me know in the comments below. But if you pay a little more attention or do a quick Google search, you'll realize that the direction a toilet bowl swirls is mostly determined by its design, specifically how the water is jetted into the bowl, not the Coriolis effect. When you flush, water from the tank rushes down into a rim located just under the seat. Some of this water flows through holes at the bottom of the rim, hitting the sides of the bowl, while the rest gets blasted through a larger siphon jet at the bottom, flushing away, well, you know. These holes and jets clearly have a direct impact on the direction of the water swirl. So, is the direction of the swirl in your toilet, and for that matter, your bathtub, sink, or bathroom floor drain, actually influenced by the Coriolis force? The answer, it seems, is likely no. In reality, there are quite a few factors that influence the direction of the water swirl. The first is whether the initial flow is clockwise or counterclockwise. When you release a stream of water, you're definitely going to create an initial flow. And even if the water surface looks completely still, its initial flow might not have completely stopped and will directly affect the direction of the swirl. So, according to Scientific American, a reputable US science magazine, it could take more than a day for this initial flow to disappear completely. Besides the initial flow, the shape and symmetry of the drain, the geometry of the plumbing system, and even your breath and air currents on the water surface can all influence the swirl direction to some extent. Additionally, the Coriolis effect gets stronger as you move towards the poles and weaker towards the equator, meaning that conducting an experiment about the Coriolis force in a single location isn't entirely accurate. Again, according to Scientific American, the acceleration caused by the Coriolis force at mid-latitudes, the pink area on the screen, is only about 1 in 10 millionth of the acceleration due to gravity. Way too small to overcome the local factors we just discussed. So to sum it all up, the Coriolis effect is real. It's simply the apparent deflection of a moving object within a rotating reference frame. On a large scale, the effects of the Coriolis force can be clearly observed in natural phenomena like wind, hurricanes, ocean currents, and in some man-made objects like airplanes, long-range artillery, and ballistic missiles. However, on a small scale, like in your toilet, bathtub, sink, or bathroom drain, the Coriolis force is overshadowed by local influences such as the initial direction of water flow, the shape and structure of the drainage system, and even air currents on the surface. And therefore, it's almost impossible to predict the direction of the water swirl based on the hemisphere you're in. Thanks for watching Facts 5 Minutes. Let me know in the comments if you've ever tried to test this toilet myth yourself. Don't forget to like, subscribe, and hit that notification bell for more fascinating facts. See you next time.